Please join us in welcoming Liangjie Hong, connecting live online.
All right. Can everybody hear me? Okay. I assume we can get started. Uh, Thank you, everybody. Also, I'm very glad to be here, and thank you for having me for this wonderful conference. I'd love to talk a little about my thoughts around how we can use AI in telecom. So this presentation is not about any particular technology or anything around a particular model and whatnot. This is primarily around my thoughts of how we can build AI products from my past almost 20 years experience of doing it, as well as my a few months of joining Nokia and thinking about how we can do it for telecom. Um, so who I am, right? So why we are here, why I'm here. So I'm Liangjie. I recently joined as a head of AI for CNS in Nokia, and I'm super happy to joining Nokia as well as telecom. I'm certainly a newcomer to the industry as well as the company. Um, at early of my career, I joined the Yahoo Research first as a research scientist and later become a manager. We were doing a lot of massive news recommendations and building massive uh, search engines at that time. We were trying to figure out how to personalize, news articles on Yahoo homepage, serving hundreds of millions of people. That was my first taste of really building large-scale AI product, in real world. And then I moved to a e-commerce company, Etsy. Um, some of you might heard about this brand. Uh, that was the headquarters in New York City. So I moved to New York City for a few years, and at that time, it was the beginning of deep learning taking off around 2016, almost already a decade ago. So I started to build up the data science and machine learning capabilities in Etsy. We were trying to use AI for shopping experience, like search, like shopping kind of recommendations, as well as building the advertisement capabilities, right? So how can we manage both the promoted content as well as the organic content? At that time, I also got exposure to early days of cloud. So at Sea, we had data centers at the beginning, and then we migrated to Google Cloud at that time. So we were working on early days with Google Cloud of how to really utilize their ML capabilities for Etsy. Um, at the same time, I also was exposed to using AI for marketing, using AI for sales. A lot of functionalities. Folks are, uh, at the beginning of thinking about how this technology can be applied. A few years later, I moved back from New York City to California, joining LinkedIn, and I spent the past 5.5, almost a half decade over there, building AI applications, building AI systems for what we call it a job marketplace, essentially connecting job seekers and recruiters. And we also need to monetize on top of that. So what is this AI system should look like, right? So it's a very complex kind of eco environment. But I was very happy about the things we are building because we had a huge impact with regarding every single job seekers were finding jobs via LinkedIn. We build a lot of LLM-based systems and so forth. So that's really gave me a lot of exposure how how the AI systems can be connected to larger goods in society, helping people find jobs. So that's a quick introduction about myself and my past many years of doing AI. But this whole AI field is moving very fast. Even today, I feel every day very fresh and certainly very feeling that kind of a feeling in with I'm joining Nokia. A lot of things I think we have a greater potential. So I shared a few thoughts with regarding that at the second part of the presentation. So the first part I'll talk about a few ideas or thoughts that I have regarding hey how building a lot of these AI applications and the products. What are the things I feel it's unique that I would love to share with this audience? And so I picked uh, three things that I would love to talk about today. So the first one is um, a lot of folks get into AI and not only engineers, right? So product managers, leadership, and whatnot. And the first ever thing folks will get very excited about, will get very confused, or sometimes get very frustrated very soon is that AI is more than a software, right? It's definitely uh, beyond just building a piece of software. So if we only thinking about boxing a software that will make us uh, sometimes hinder us really shape AI products. So that's the first foremost I would like to convey. The second part is it's really the data, even though we are talking about AI, but the data is super important. Without data, AI is not going anywhere. So I've heard about a lot about AI across the industry. Not everybody is clear about their data strategy. So I would love to briefly touch that as well. Last but not least, AI also is I wouldn't say the only one, but certainly benefit greatly from both the research and the development in the field, and it's a very vivid community going on there. So if you are building AI solutions, if you are building an AI team, if you are hiring engineers, uh, R&D have to go hand in hand, and you have to, if you are a leader, you have to keep that in mind. Okay, so of course each one of these probably deserve many hours deep dive and so forth. But I would like to give a flavor of what ideas I'm talking about here. So the first one, right? So let's talk about AI. It's not only software engineering, right? When we are talking about software engineering, we are talking about, right, or at least some classic image is okay. We have some scope, we have some features want to deliver. We are going to measure them as ETAs, right? So when I was in a lot of my former companies, and I'm talking to industry friends, everybody talking about ETAs, right? Where you want to hit your milestones, where you want to ship your products, and so forth, right? So nothing wrong there. Okay, but one thing I want to point out, and then you immediately understand this is beyond the ETA, right? So you're thinking about OpenAI, thinking about the Google Gemini, right? Now, if AI is as simple as shipping software, why these companies, right? So the biggest one with a lot of good talents, a lot of good engineering teams, a lot of good infrastructure, they will still have a hard time to release their flagship models in a fixed time interval. Okay, so they should be able to ship their AI product every 3 months. Yeah, there is a very deterministic or guaranteed milestones they can hit. And the reality is, no, nobody can do that. Like, if you can recall, right? So GPT-5 has been released, probably more than half a year ago. Gemini 5.2 also released probably more than 5 months ago. So this is not a about a fixed time release, right? So because we're talking about what? We're talking about models. We're talking about the model improvement and the rules regarding their quality, right? Things like accuracy, things like precision and recall, and so on and so forth. These, unfortunately, even sometimes you have the best team in the world, even you have the best compute environment in the world, they may not necessarily have a single deterministic path you can go there. So that's why you have to manage this uh, from the angle of probabilistic execution path, right? What I mean by probabilistic execution path, that means there could be multiple routes, right? So multiple paths from execution standpoint. It's not like a one, even though destiny can be one, right? So, oh, I want to ship GPT-6, but internally, you would have multiple teams working on slightly different set of the hypothesis or experiments to be able to reach there. And the more confidence you want to build, the more so-called deterministic you want to build in, the more paralyzation, unfortunately, you have to kind of embrace. So this whole idea of probabilistic multiple paths of execution, uh, a lot of times when I engage with engineering leaders, this blow people's mind at the beginning because that means you have to manage your so-called backlog very differently. So like I said, this whole topic we can go very deep, but this is the first one I want to share with this audience, right? So AI certainly deserve and require we look deeper in terms of how we are thinking about software engineering, how to shape AI artifacts. The second thing, like I mentioned, right, data strategy is very important. Now, why that's a case, right? So can we do it without data? Now, unfortunately, we cannot because we're talking about the piece that we evaluate how good your AI product slash solutions is, right? So this is the key in the metrics and the measurement. Thinking about from GPT-4 to GPT-5 to GPT-6, OpenAI has they internally has very a very kind of rigorous measurement framework such that they know how much they're making the progress, and if they're not making enough progress, they're not going to release the model. That's why also I mentioned in the previous slides that it's not deterministic. Um, now this evaluation built on top of data, right? So how the model is behaving on, let's say, math problems, how the model is behaving on figuring out the chemical problems, how the model is behaving on other things. So everything is about data. So this is very, very critical. Now, what you are doing with data? You are doing experiments. You are doing many, many experiments, right? So in my former roles, and I also heard from other sister organizations, that's probably roughly the magnitude we're talking about here, which is running thousands, hundreds to thousands of experiments per month. So these experiments helping us to learn, right? Helping us to iterate, helping us to making marginal improvement over our kind of models and so forth. And of course, as you do many of these experiments, then failed ones are also very common, right? So there's a kind of the common knowledge in the industry where only one third of maximally actually one third of experiments are successful. So how do you have that lab environment, and how do you how do you have the things that you can iterate over time is very important. The last thing I want to talk about is this R&D notion, right? So um, AI in the last decade benefit hugely from research result. So this is a research from both industry as well as academic. This is probably very unique in from many other domains because in many other domains, the transfer of knowledge, transfer of ideas from from research to the real world takes years, if sometimes decades. Now in AI, that is almost instant, um, and this also pushed a lot of very massive transformation of certain fields like natural language processing, computer vision, information retrieval. A lot of these subfields in computer science, they used to be very distinct from each other. They have different methodology, they have different ideas, systems, and whatnot. They are all converging to a kind of a more unified architecture, unified AI solutions nowadays built around transformers and the hardware building around the GPUs. This is this has never seen before in even in computer science, certainly not in other domains. So this is why paying great attention to research result as R&D as leaders is going to be very important because a lot of this trend can fundamentally change how we are building systems. Um, Last but not least on this is that on the this the other side, right? So from the development side, this is also this field is greatly benefit that at a very beginning this has been treated as an engineering discipline, right? So that's why we have TensorFlow, PyTorch, many other open source libraries and framework that has been very robust build. It's not just lab code. It's not like back when I was a graduate student, we had MATLABs in the laptop and whatnot. This is way beyond just some research code. A lot of code has been developed by professional developers with the research ideas. So nowadays you can go to many website and download PyTorch based the latest research result and directly plug in your pipeline within let's say a few hours, even longest a few days. That this is insanely beneficial for the community. Okay, so these are the three things. Again, like I mentioned, right? So hopefully you can think about them. All right. So after this conference in your daily life, and also happy to connect. Everybody has more deep ideas about them. But the next is I would love to share a few thoughts around how AI, I think, can shape telecom. Right. So again, these are some of the few the early ideas. And I would love to talk about uh, two groups of ideas that I think worth to invest in, and also as we're in CNS, we are already moving some of the needles. Now, I don't want this as a project review and deep dive. So this is more like thinking about as a themes that worth us to think about. So for the short term, I think the first one probably is there's no doubt that AI can do a lot. I'm talking about a lot, massive skills in terms of automation, right? So this is where I think we have so many so-called, I would call it the low-hanging fruit. We are also doing this with many pieces in CNS, like packet core, like security, like autonomous network as well. Uh, that we are really looking into the steps, right? So especially things like upgrading this network, installing software, and so forth. If you have many manual steps, how can we figure out if at any step we should do triage a problem or go back, roll back or some other actions. So we're building agentic capabilities into automation in network operations, such that we know exactly what's the next best actions powered by anomaly detections and the root cause analysis of these tools. So this is a short-term focus for CNS, and we are going to have a few areas to really bring this live. Like I mentioned, the first probably around the packet core, but we are also are going to bring this live in a few agency areas as well. The second thing we are doing, and also I feel is very important, like I mentioned earlier, right? So without data, everything is a fantasy. So we have to be very serious about our data strategy. Now, this autonomous network fabric, ANF in short, is something we are bringing the data, bring different source data source along to be able to massaging them, to be able to generate insights and so forth. So this is certainly one of the things that is very foundational, and we should be able to show great values once we have different source of data, and this source of data, right, so can be used for building future applications. The last area I want to mention in the short-term pillars is really building AI for understanding our classic code base, right? Because we have primarily C and C++ code base and many decades of uh, human engineering kind of capabilities and human engineering expertise building, which is great. But how can we really leverage AI in there such that we can transfer some of the the intelligence, right? So from the code base to humans, such that we can talk to the code base, we can ask questions, we can even generate some entry level code test to engineers, to enter the engineers, and we can even generate kind of more complex artifacts, right? So like config files, like design files, like workflow files, and running script and so on and so forth. So this is definitely another very big domain, and we are also starting to work on it. And of course, there's going to be a lot of partners. We're like Bell Labs and whatnot. We're partnering to figure out how we can build AI on top of that, right? So this is the third pillar that we are going to focus on in short term. Okay, so hopefully this give you some ideas, right? So again, this is not exhaustive project reviews, but these are the three areas that in CNS we are going to spend more time building AI for them. At the same time, right, we're going to build some foundation layers, right? So if there are certain components that is going to be common, we are going to build them as well. So in the last few minutes, I would love to share a few long-term pillars. I think it's going to be very ambitious, and hopefully this is also kind of inspiring folks in the room and online to think about how to build all these innovation technologies. One disclaimer is these are like early thoughts. I very much welcome any comments and feedbacks from your offline. I know we cannot do the QAs and so forth, but anything you want to chat, I'm happy to engage. The first idea is we really have to go beyond agentic system, right? So because agentic system is great, we're wrapping our legacy system around LLMs and so forth, right? So that's I just mentioned, in a few slides earlier, that are something we are focusing on as a short-term pillar. But inevitably, we have to go in deeper into all these legacy systems so that we can't treat everything as a black box. So one uh, way, which is I would call it AI native stack, essentially is we use models, and here I'm talking about deep nets and particularly transformers to replace some, if not all of those modules, and and have the equivalent functionalities, while this AI native stack would benefit from much simpler software layer because we are going to move to the more like modern PyTorch, Python related. I'm not saying that's only, right? Because you can compile that in C anyhow. There's a lot of tooling there, but I'm using PyTorch as a talking point here, right? So moving that to a PyTorch software ecosystem, and the hardware is going to be GPUs, commodity GPUs. So everything is going to be more like a commodity data center setup. So this will give us huge benefit because we're talking about potentially moving from hundreds of C++ legacy systems to much fewer model-based uh, the approach, right? So this is something that I feel that we should think about how to build this. I heard that when I visited Bell Labs a few months ago, I heard that Huawei also thinking about the similar things in 6G, which is great. I think this might be something would be very fundamentally changing the game, right? So how do we really build the AI native stack? Now, on top of that, right? So once we have AI native stacks, um, we thinking about a lot of AI workloads can run it more naturally, right? For instance, autonomous cars and self-driving cars. Today, let's say you have Teslas, they must already have some computer vision algorithms running on their cars, right? Because they have to detect the things on the road, but they may not able to communicate from a semantic point of view, right? So with the cell towers, with data centers, because they are running on different tech stacks. Now, in future, once we move to AI native stacks, that part of the Tesla also can be run on similar computer vision algorithms that can be PyTorch, and there's some GPU equivalent on Tesla as well. So the Teslas, right? So if you have two kind of Teslas on the same route, they can communicate with cell towers properly, right? So this you can have a massive distributed computing environment over there, so which is going to be great beneficial to the whole network. So folks are giving me idea that I'm running out of time. So that actually I only have one slide. So this was the last slide, in fact. So the other thing I feel like we should be thinking about is thinking about all the CSPs as a supply side of platform and thinking about all the workflows as a demand side platforms, such that we can build a marketplace to match supply demand, right? So there's a lot of marketplace on the internet domain, right? So Uber, e-commerce like Amazon, Google as like AdsNet, all are multi-billion-dollar business, and this is a great way to really allocate the resource, really manage scarce resource and being able to dynamic manage them. So something like that, I think, as a telecom, we should think about. Okay, so with this, hopefully you get a overview of a lot of things happening in CNS, and as well as I mentioned earlier, a few meta points I would love to share with this audience from my journey. And if you have questions, if you have comments, feel free to reach out to me. And thank you again for the organizers to having me here. And yeah, that's all my presentation is about today. Thank you.